Hi friends, welcome to CMT tutorials. So today we are going to discussing about the transfer characteristics of operational amplifier. So transfer characteristics means it is a graph between output voltage and difference input. Okay, transfer characteristics means it is a graph between it is a graph between output voltage and difference input. Okay, so we know that generally op amp is nothing but it can be recognized, can be represented as like this. Okay, so this can be treated as a V naught, consisting of inverting and non-inverting inputs. So I will consider V1, V2, okay, plus minus. Okay, so we know that generally V naught is equal to output voltage V naught is equal to open loop gain AOL into V1 minus V2, right? So we know that generally VD is equal to VD. We know that VD is equal to difference voltage is equal to V1 minus V2. Therefore, output voltage V0 is equal to AOL into VD. Okay, so this is the output voltage in terms of open loop gain and difference voltage. Okay, okay. Now see the transfer characteristics for ideal characteristics. Okay, what are the ideal characteristics of op amp? So ideal op amp. Okay, ideal operational op amp. So we know that generally for ideal characteristics of op amp, we know that open loop gain, open loop gain for ideal op amp is infinity. Okay, it is a value. It is a well-known point for everyone, right? Suppose, suppose, suppose if the difference voltage VD is greater than zero, then V naught is equal to plus or minus plus infinity. So it is approximately equal to plus VCC, that is equal to plus V saturation. The maximum operating voltage for ideal op amp is equal to plus Vsat. Moreover, suppose if the input voltage, if the difference voltage is less than 0, then output voltage V naught is equal to minus infinity. So it is approximately equal to minus VCC, that is equal to minus Vsat. Vsat is nothing but saturation voltage. Okay, this is the ideal characteristics of operational amplifier. Therefore, based on this one, if you draw the characteristics for ideal case, I will draw here. Ideal characteristic. Okay, these are the ideal characteristics of operational amplifier. So this is nothing but output voltage is plus Vsat it is nothing but minus Vz. So these are the ideal characteristics of the operational amplifier. Okay. Next, for non-ideal characteristics of op-amp, the second case is nothing but non-ideal op-amp. So it is generally non-ideal op-amp is nothing but the IC number for IC 741 is a number. Okay. So AOL is equal for non-ideal case. Open loop gain AOL is equal to in terms of 10 power 6 or some finite value. Ideally, this value is infinite, but if you go for the non-ideal characteristics cases, the open loop gain of the non-ideal op-amp is equal to 10 power 6 range. Therefore, if difference voltage VD lies between minus Vsat by AOL or plus Vsat by AOL, V0 varies linearly with VD. Okay, range. The output voltage V0 varies linearly with VD, that is nothing but difference voltage. If VD is outside the above range, V0 remains constant at plus Vsat or minus Vsat. If suppose in case if VD, okay, right, this VD is let us here. If VD is outside range, V0 remains at plus Vsat or minus Vsat range. Okay, when the op-amp is used in the open loop condition or with a positive feedback, the difference VD will be large enough. Therefore, op-amp works in the saturation region. Suppose it is also one more important point. If op-amp in open loop or positive feedback, the difference will be difference input VD is large. So output V0 is equal to plus Vsat. When op-amp is used in the negative feedback, difference input VD becomes negligibly small. So this is also very important in case if op-amp in negative feedback, VD is negligibly small, and hence op-amp works in linear region. Op-amp works in linear region. Negligible. When op-amp is used with negative feedback, the difference input Vd becomes negligibly small. So negligibly small. So op-amp works in a linear region. Op-amp works in linear region. In negative feedback circuits, op-amp Vd is very small, hence it can be approximated to 0. Mathematically, Vd is equal to 0. In negative feedback op-amp, Vd is approximately 0. Therefore, Vd is equal to V1 minus V2. So Vd is equal to 0 means that V1 minus V2. Therefore, V1 is equal to V2. V2. If the negative feedback circuits inverting and non-inverting nodes of op-amp are almost at equal potential without any physical short circuit. Okay, in a negative feedback circuits, it is also available in negative feedback circuits, both inverting and non-inverting nodes of op-amp are almost equal potential without any physical short circuit. Equal potential without any physical short circuit. Okay, between them. Those are short circuit between them. Hence, inverting and non-inverting nodes are said to be virtually short circuit. Therefore, inverting and non-inverting nodes are short circuited. Okay. So concept of virtual circuit is applicable to the op-amp circuits having a negative feedback. Therefore, from this concept of virtual applicable for op-amps with negative feedback. Okay. Second one is nothing but input bias current. Okay, next point. input bias current. Okay, it is the average of two input currents of op amp. Input bias current means that it is the average of two input currents. Okay, op amp. Therefore, input bias current I bias is equal to V1. Sorry, in terms of you can represent current side. Input current II1, input current II2 by 2. Okay. Okay, this is nothing but input bias current means that it is the average of two input currents of op amp. Input offset current, it is a difference of two input currents of op amp. That is nothing but difference operator. Okay, input offset current. Next one is nothing but input offset current. Input offset current means it is a difference of two input currents of op amp. Input, it is the difference of two input currents of op amp. Therefore, it can be written in difference of is equal to II1, II2. It is nothing but a difference operator. Output offset voltage. Next one, output offset voltage. What is meant by output offset voltage? It is the output voltage of op amp when V1 and V2 is equal to 0. Okay, it is the output offset voltage means that it is nothing but output voltage of op amp, output voltage of op amp when V1 and V2 equal to 0. So when the input voltage is V1 and V2 is equal to 0, at that time whatever the output voltage is present at the op amp, that output voltage is generally called as a offset voltage. VOD is due to dissimilarities in the transistors used in the difference amplifier stages of op amp. Okay, this is nothing but VOD, output offset voltage. So this is nothing. VO means that output offset voltage is present due to dissimilarities dissimilarities is between the transistors. Okay, so VO is in the form of a tens of millivolts to few volts range. This VO range is range from hundreds of millivolts to a few volts. So this is a range of output offset voltage. Next one, input offset voltage. Next one, input offset voltage means that input offset, it is the non-zero voltage which should be applied as a difference input to the op amp to make the output voltage 0. Okay, it is a non-zero input voltage applied to op amp to make output voltage 0. To make output voltage 0. Okay, so this is a minimum voltage, the voltage which is required to make the output voltage of the operational amplifier to the 0. అంటే మనకు ఆపరేషన్ యాంప్లిఫైర్ లో 0 కాలేదంటే we need some voltage to make that voltage to 0 conditions అని. So if the input offset voltage varies with the changes in the supply voltage. Okay, this voltage is changes with the supply voltage. If you draw the circuit diagram like this, okay, this is the difference of offset voltage to make output voltage to 0. Next one, power supply rejection ratio. Next one, power supply transfer characteristics. The next point is nothing, power supply rejection ratio. Power supply rejection ratio, that is nothing but we can call simply PS, power supply rejection ratio. Okay, so it is a measure of change in the input offset voltage due to changes in the supply voltage. So it is a measure of power supply ratio can be, it is a measure of, it is the measure of, it is a measure of change in input offset voltage, measure of change in input offset voltage due to changes in supply voltage. Therefore, PSRR in TV is equal to 20 log of. So decibels means obviously we can represent 20 log of change in the supply voltage delta Vs by change in the offset voltage, input offset voltage. Okay, so these are the transfer characteristics of the operational amplifier. Let us see in a very few description. తెలుగులో చూద్దాం. సో ట్రాన్స్ఫర్ క్యారెక్టరిస్టిక్స్ ఆప్ యాంప్ అంటే ఏం చేస్తుందంటే ఫస్ట్ ఈ ట్రాన్స్ఫర్ క్యారెక్టరిస్టిక్స్ మీన్స్ ఏంటంటే అవుట్పుట్ వోల్టేజ్ కి డిఫరెన్స్ ఇన్పుట్ కి డ్రా చేసే గ్రాఫ్ ని మనం ట్రాన్స్ఫర్ క్యారెక్టరిస్టిక్స్ అని చెప్తాం. ఐడియల్ క్యారెక్టరిస్టిక్స్ లో ఏమవుతుందంటే వెన్ ద ఇన్పుట్ వోల్టేజ్ దట్ డిఫరెన్స్ వోల్టేజ్ గ్రేటర్ దెన్ 0 అయితే ఆపరేషన్ యాంప్లిఫైర్ అనేది ప్లస్ Vsat లో వర్క్ అవుతుంది. ఇఫ్ ది డిఫరెన్స్ వోల్టేజ్ ఇస్ లెస్ దెన్ 0 అంటే దట్ వర్క్స్ ఇన్ ద మైనస్ Vsat రేంజ్ లో వర్క్ అవుతుంది. సో దట్ కెన్ బి రిప్రజెంటెడ్ యాజ్ హియర్. ఓకే, నెక్స్ట్ ఏమని చెప్తున్నాం, నెక్స్ట్ నాన్ ఐడియల్ క్యారెక్టరిస్టిక్స్ ఏమవుతుందంటే ఆపరేషన్ యాంప్లిఫైర్ అనేది ఓపెన్ లూప్ గెయిన్ వోల్టేజ్ ఈస్ నాట్ ఎగ్జాక్ట్లీ ఈక్వల్ టు ఇన్ఫినైట్ బట్ ఇన్ టర్మ్స్ ఆఫ్ సమ్ ఫైనైట్ వాల్యూస్ అంటే దట్ ఈస్ నథింగ్ బట్ 10 పవర్ జీరోస్ ఫార్మాట్ లో ఉంటుంది. అండ్ ఇఫ్ ది డిఫరెన్స్ వోల్టేజ్ అవుట్ సైడ్ రేంజ్ లో ఉంది అంటే ఇట్ ఈస్ రిమైన్స్ కాన్స్టెంట్ ఎట్ ప్లస్ Vsat లో కానీ లేదా మైనస్ Vsat లో వర్క్ అవుతుంది. ఓకే, సో సపోజ్ ఇఫ్ ది రేంజ్ ఈస్ ఇన్ బిట్వీన్ దీస్ టూ లో ఉందంటే అవుట్పుట్ వోల్టేజ్ remains in the linear region. At that time this different voltage output voltage is act as a output voltage V0 varies linearly with VDN. Okay, so that is in case of the negative feedback what happens is that this difference voltage is very small. Okay, in case of the negative feedback where difference voltage negligibly small, so op amp works in the linear region. Moreover, this difference voltage is linear means in negative feedback Vd is equal to 0. That means difference voltage 0 means input and output voltage both Vi and equal to V2. If the negative feedback circuits both inverting and non-inverting, okay, in case of the negative feedback both inverting and non-inverting nodes of the operation amplifier అనేవి ఆల్మోస్ట్ ఈక్వల్ టు ది ఈక్వల్ పొటెన్షియల్ అంటే ఏంటి, రెండిట్లో సేమ్ వాల్యూ ఉంది అంటే దట్ మీన్స్ దే ఆర్ ఫిజికల్లీ షార్ట్ సర్క్యూట్ బట్ దే ఆర్ నాట్ రియల్లీ ఫిజికల్లీ షార్టెడ్. therefore that kind of the situations are generally called as a virtually short circuit. Okay, those two nodes are virtually short circuit. This is one of the most important point for negative. This short circuit concept is only applicable for the negative feedbacks మాత్రమే వర్క్ అవుతుంది. This is one more important point, right? సో ఇన్పుట్ బయాస్ కరెంట్ అంటే ఏంటి, ఇన్పుట్ సైడ్ ఉండే కరెంట్ ని మనం ఇన్పుట్ బయాస్ కరెంట్ అంటున్నాం. ఓకేనా, సో దట్ ఇన్పుట్ బయాస్ కరెంట్ మీన్స్ దట్ ఏం చెప్తున్నా అంటే ఇన్పుట్ బయాస్ ఇట్ ఈస్ ద యావరేజ్ ఆఫ్ టూ ఇన్పుట్ కరెంట్స్. ఓకే, ఇట్ ఈస్ ద యావరేజ్ ఆఫ్ టూ ఇన్పుట్ కరెంట్స్. therefore ఇన్పుట్ బయాస్ కరెంట్ IB okay, input bias current. Input offset current, difference of two input currents is nothing but input offset current. Output offset voltage, difference of two output voltage. Input offset voltage is the difference of non-zero voltage applied at the op amp side to make the output voltage to 0. Okay, so power supply rejection ratio means that it is a measure of change of the input voltage due to the supply voltage changes. So this is nothing but transfer characteristics of the operational amplifier. I hope this video is helpful for you. Thank you for watching GMK tutorials.